Hey, geometry, lesson 11. Perimeters and areas of polygonal regions defined by systems of equalities. So we've done a bit of systems of equalities and how that defines regions in a coordinate plane. And we've done perimeters and areas of polygonal regions. So now we're just marrying these two together. First, let's do a little bit of review. Graph the following. So first of all, y is less than or equal to 7. First we have to find y is equal to 7 on our coordinate plane. 1, 2, 3, 4, 5, 6. Of course 7 is not on here because that makes sense. There is 7 and it's less than or equal to, so I'm going to draw a solid line at y equals 7 and then shade under the line. Okay, so everything above the line is not shaded, everything below the line is. Let's try y is greater than or equal to -3. So I'm going to go, sorry, x. X is greater than or equal to -3. I'm going to go to x equals -3. 1, 2, 3. And I'm going to draw a dashed line at x equals 3. Then I'm going to shade everything greater. So everything on this side of the coordinate plane is included in that solution set. Two more, a little bit more difficult. Y is less than or equal to 1/2 x minus 4. First I'm going to graph equal to. I go down to I go down to my y-intercept at -4. 1, 2, 3, 4. Put a dot. And then I'm going to use my slope, rise over run, to graph the rest of it. So rise of 1, run of 2, rise of 1, run of 2, rise of 1, run of 2. Okay, down 1, left 2 works also. And this is just less than, so I'm going to put a dashed line. And you can either figure out that y is less than 1/2 x minus 4 would be below, or you can test a point. You can put in 0, 0 and see if it is true, a true statement. So 0 for y, 0 for x. Is 0 less than or equal to -4? No. So 0 should not be in the solution set. So you should shade everything else, not 0. Okay, let's try this one. We have a y-intercept of 5. We're going to go up 1, 2, 3, 4, 5 and put a dot. A slope of -2/3. So I'm going to go down to +3, down to +3. And it's greater than or equal to, so we have a solid line. And you can either figure out that it's greater than, so I'm shading above, or you can test the origin. 0 greater than or equal to 0 plus 5. Is 0 greater than or equal to 5? No. So the origin should not be in your solution set. Cool? Cool. Alright, let's get into the meat of the lesson. So a parallelogram with a base of length b and a height h can be situated in the coordinate plane as shown. Verify the shoelace formula, or Green's formula, remember, gives the area of a parallelogram as BH. So what is the area of a parallelogram? We know that area, I'm still in highlighter. Area equals b times h, right? Now let's look at this. I have the distance from the x-axis to the top left vertex right here as some number x. So my ordered pair here is xh, right? Top right vertex. Okay, what are the coordinates of the top right vertex? I know it's a parallelogram, so the distance from here to here is going to be equal to the distance from here to here. So I can safely say if this length is b, then this length is b also. So this point right here is going to be x plus b, comma, h, right? The bottom side starts at the origin where x equals 0. So here I'm going to have 0, 0, and And over here, I'm going to have B 0. Right? I think that's it. I think I have everything. So now I'm going to list the coordinates starting at the origin and moving counterclockwise. So I have 0, 0. I don't need parentheses, do I? 0, 0. Then I have B0, x plus BH, and XH. Now we're using the shoelace formula. So I'm going to draw my fun lines in different colors so I can see them. Then I'm going to do my math. All right, first I have the addition. Oh, goodness, there we go. 0 times 0 plus B times H plus X plus B H plus X times 0 minus, do the blues, 0 times B minus 0 times X plus B minus XH minus H times 0. Okay, get rid of everything that I don't need, or that cancels out really. That means I have BH plus, I'm going to distribute this, XH plus BH minus XH. That means these are gone, and I have, oh, silly me, I forgot something. There's a 1/2 up here. Do you guys see it? Because I was really wondering, wait, I have 2 BHs. I can't have 2 BHs. So 1/2 times 2 BH equals BH. We did it! Is anyone else as excited as I am? No? Alright. Alright, let's try another example. A triangle with base B and height h can be situated in the coordinate plane as shown. According to Green's theorem, what is the area of the triangle? So area of a triangle is 1/2 base times height. Let's see, over here I have 0, 0. And then up here I'm going to say I'm at x comma h. And here B comma 0. Those are my ordered pairs. And I'm going to go ahead and order these from the origin counterclockwise and work on my shoe lace. Still want to say shoestring. I'll probably do this one without, but it's okay. So 0 times 0 plus B times H plus X times 0 minus 0 times B minus 0 times X minus 0 times H. So get rid of all the junk, and I'm left with 1/2 base times height. It's like magic. Cool. Now let's sort of marry what we've done together. So the first thing we did for this lesson was drew some lines and shaded. The second thing we did for the lesson was use the shoelace theorem or Green's theorem to calculate area. Now we're doing them together. So first let's go ahead and draw our lines. So a quadrilateral region is defined by the system of inequalities below. Let's go ahead and sketch it. 1, 2, 3, 4, 5, 6. A slope of +1. Be patient with me. Go ahead and draw on your own if you'd like. Yours will most likely be much neater than mine. And I'm going to shade down when I get around to it. I don't want to make my graph too messy. Next, I have oh goodness, a y-intercept of 12 and a slope of -2. That's near impossible to do. Let's see. I'm going to go ahead and graph it in Desmos and see what my x-intercept is y equals 0. So my x-intercept is going to be 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And my slope is -2/1. So a rise 2, rise 2, rise 2. There we go. And it's less than, so I'm going to shade in. Next we have -4, 1, 2, 3, 4, and a slope of 2/1. 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. Awesome. Let's see if I can draw a straight line. And lastly, let's get our handy dandy green. I have an x-intercept of +2 and a slope of -1. And I'm shading up. Cool, so let me shade this and then I'm going to take a break, go teach, and come back. This right here is my shaded region. Okay, the next thing I need to do is find all the ordered pairs, right? Determine the vertices, so I'll be right back. Now the vertices, you've drawn yours on your worksheet much nicer than I've drawn mine, so you'll be able to see them a lot better. But I see over 2 up 8, over 4 up 4, over 2 up 0, and -2 up 4. Let me write those down though. 2, 8, 4, 4. We're really lucky they all hit at points that we can read on our graph, right? Otherwise we'd have to set our equations, our linear equations, equal to each other and solve for x and y to find where they intersect. Alright, now find the perimeter of the quadrilateral region. I'm going to get that out of the way and do that in a little bit. So the perimeter, that means that I need to find the distance of each diagonal. So I've got lots of right triangles that I can quickly do the Pythagorean theorem with. I think I'm going to do that offline though. Cool. So I'm going to push pause and work through the measurements of each one of those hypotenuses. Or is it hypotenusae? Just kidding. Alright, I found, excuse me, the length of each side of the polygon of the quadrilateral, added them together, and I have my perimeter. Okay, let's move on to the next slide to do the area. And I'm using the shoelace formula, or the shoestring formula. I can't remember. Shoelace. Or Green's formula. Green's theorem is just easier to remember, since I seem to keep getting shoelace and shoestring confused. So I'm going to go ahead and I'm going to start at A and go counterclockwise on the next page to do the area. So my area is going to be 1/2. -2 times 0 is 0, plus 2 times 4, plus 4 times 8, plus 4 times 2, minus the blues, 8, minus 0, minus 8, minus a -16. Let's get rid of, I got a +8 and a -8, a +8 and a -8. Those are added together. So that gives me 1/2, 32 plus 16, 8, 3, 6, 7, 8, 348, which equals 24 units squared. Awesome, that was fun. I like the shoelace formula. All right, let's do another one. I'm going to push pause and do all my sketching. I would ask you to do the same. All right, there we go. Determine the vertices of the region. I've got -4, 1. We're going to make that A and go counterclockwise. Then it looks like I have 0, -4. And then over here, I'm at 8, 4. So this was B. C, I'm at 8, 4. And then D, -1, 4. Awesome. Which quadrilateral is defined by these inequalities? It's really cool. I'll do it in blue. Let's see. I have a slope of 1 and a slope of 1. So these two lines here are parallel. Right? That gives me a trapezoid. And to prove that conclusion, my slopes are equal. My m's are equal. Cool? All right. Find the perimeter of the quadrilateral region. So I need the lengths of all the sides. Okay? So I'm going to go offline and do that. You can do the same and check your answer. Okay, I got 30.96. Don't forget this one. It has to be added in with all the others for the perimeter, and I just used the Pythagorean theorem to find it. Now I need to do the area. I'm going to list these values clockwise, starting at A. Alright. Alright, I'm going to do yellow, add the yellow, subtract the blue. -4, -4 is 16 plus 0 plus 32 minus 1. And then subtract the blue. -0 minus a -32 minus a -4 and minus a -16. Let's see. This would be plus, this would be plus, this would be plus. I've got a +2 and a positive. Wow, those are big numbers. So 16 plus 32 plus 32 plus 16 plus 4. I just had to go back and fix that because I forgot. Oh gosh. I forgot the -1. So this gives me, 1/2 times 99, which is 49.5 units squared. Cool? Yeah, I just made a mistake, so I fixed it. Nice work today. That's all I got.